realize that there is a long line for the food. Sorry about that. But hey, timing is timing, right? So we have to get started. All right, so first of all, welcome for our second Billing and Engineering Payments Meetup. Billing and Payments Engineering Meetup. So we had a first meetup last year, and if you are interested in learning more about it, you can find it in our Netflix tech blog. So tonight there will be 5 presentations from 5 different teams. We have some demo booth that is installed here. So if you want to have a look and meet the engineering team, that's also a good point. We have some food and drinks over there. So, feel free to go and grab some stuff. The only thing that I will ask from you is that you respect the presentations, and so don't make too much noise, of course. All right, okay, so let's get started. So hi, everyone. My name is Matt. I'm the engineering manager of the payments engineering team. And tonight, I will be telling you about how we re-engineered our payments application into the cloud. So first of all, a few numbers. Netflix, it's above 57 million subscribers worldwide across more than 50 countries. In terms of payment, we support 12 currencies, 9 different payment types, and we connect to more than 15 payment processors and validation services. Overall, if we do the math, it's around 2 million transactions that are being processed per day. And we are counting. As Netflix expands internationally, we are also opening more countries, introducing more currencies, more payment types, and integrating with more processors. So, the responsibilities of the payment application. First of all, it's responsible of storing in a secured and encrypted way your payments information. We call it your method of payment, it's your MOP. We are also responsible for connecting to all the different third-party and verification services in the context of payment processing. Also, we do a lot of batch processing in the backend. And finally, but this is really important for us, we also want to expose an agnostic interface to all the other services inside Netflix that would be calling us. This way, we can abstract from them all the complexity of the various payment types and payment flows. Our historical payments application has been running in the data center. And there were some cases where there were some payment types, and especially payment flows, that turned out to be a bit painful to integrate, especially when the flow deviates too much from the original design of the application. Also, we had developers who were coming and going, and at the end of the day, it was creating more like sedimentary layers of legacy code, so it was a bit hard to maintain. So from an architecture perspective, it looks like this. So we have our payments app that is running in the data center. It's connecting to our third-party processors, and we store the MOP and the transactions in an Oracle database. We also have some batch applications that are doing a similar job. For all the services that are still running in the data center, that are not moved to the cloud yet, we expose an API that allows them to call us. For all the ones that are already in the cloud, we have also introduced a cloud proxy. We expose the same set of APIs to them, and we connect to the data center through a tunnel. So if you know a bit about Netflix, you probably know that Netflix loves the cloud. It hasn't always been like this, right? Back in 1997, when Netflix was founded, by the way, you can appreciate that beautiful logo, so it was a completely different scale. And then, over the years, we introduced streaming, and progressively, we migrated our monolithic app in the data center to a microservices architecture in AWS. After a few years, now that we got more knowledge of the cloud and that the cloud also gained more maturity, we decided it was the right time to move critical application, like the payments application, into the cloud as well. So payments in the cloud, that's great. The very first thing that we wanted to ensure is that everything was good in terms of compliancy. And luckily for us, AWS is level 1 compliant, and if we wanted to use Cassandra, it is also now PCI compliant. We also wanted to rethink our division of labor. So a new service was introduced, a tokenizer service, and its sole purpose was to store your payment information in a secured and encrypted way. It was returning a token, and it's that token that is then being used by other applications inside Netflix. We also use Cloud HSM as a secure storage place, so we can store the encryption keys in a secure manner. Also, we did a lot of technical evaluation, and the most important of which was which database would we be choosing. Do we want to keep a relational database model, or did we want also to go really full scale and switch to a NoSQL solution? So that's what we did. We decided to choose Cassandra. One of the reasons was that Netflix also gained a lot of experience using Cassandra in the cloud, and we wanted also to benefit from all that knowledge and experience that we gained over the years. Cassandra has this specificity that it has tunable consistency, which means that you can really select and trigger your level of consistency according to your business needs. Also, it offers multi-regional support, which is really a great win in Amazon, and you can have more resiliency toward outages. So raise your hand if you know about the CAP theorem. Right, cool, many people, that's great. So basically the CAP theorem states that in a distributed system, you cannot have all of the 3 guarantees, which are consistency, availability, and partition tolerance. So in our case, what we wanted to privilege above all was consistency. And so we were able to configure Cassandra this way. Overall, when it's a payments application, what is really the most important is that you keep your transaction data secure and consistent. You don't want to, you are able to pay a little price in terms of latency as long as you can keep your data consistent. We also had to rethink our data model. Coming from a relational database, we really had to rethink the way it was designed and denormalize everything so it could better fit with Cassandra. We also reevaluated a lot of technologies and framework. We took a step back from our payments application, and then we were thinking, okay, so what could be really the foundation stones that would help us to build a reliable payments application that would be able to sustain for the future? When we looked at our payments app and the workflow that it was addressing, it was fitting really well with enterprise integration patterns. So we investigated different EIP frameworks, and we decided to choose Apache Camel. We wanted also to find the same thing for our batch applications, and we decided to keep Spring Batch that we were already using in the data center, and we are already very happy with it. For the actual forklift of all the data in the data center to the cloud, we rely on Apache Storm to migrate all this data in an efficient way. Finally, now that we are in the cloud, we can also benefit from all the open source frameworks that Netflix has been building over the years, and we are also able to use more AWS services. So in terms of the new architecture, how does it look like? So we have our new cloud payments app. It still exposes the same API to our client's application from the cloud. We use a tokenizer to securely store your method of payment. And we connect to third-party services and store our transactions in Cassandra. Everything running in the cloud, no more dependency on the data center. In terms of multi-region availability, so AWS is configured in a way that it proposes you some availability zones within a given AWS region. And when we moved our microservices into the cloud, we deployed them in every availability zone, and everything was backed up by a Cassandra ring that was allowing us to keep the data synchronized across all these different zones. And we also wanted to push it even further, so we replicated the same configuration in other Amazon regions, and using a mechanism of data replication for Cassandra, we were still able to keep the data replicated across the board and then provide a maximum level of resiliency. So now that we have our new payments application, it was just a matter of deploying it in these availability regions like these other microservices. So how do we get there? We had to go through several transition stages. And the first thing that we wanted to ensure is that we had enough decoupling between our new application and the existing operational flow. We wanted it to be really transparent so it would not impact our clients. Also, we wanted to have a safety net. So every data that was written in the cloud would also be written in the data center using Shadowwrite. This way, we can always roll back to the DC in case anything goes bad. And finally, we also had to decide what would be our migration strategy. We could not simply just copy everything in the cloud as like one batch. So we decided to go country by country. It was offering us a good level of partitioning that was allowing us to keep control of what we were moving into the cloud. So first of all, for the decoupling. So here on the left, you have the existing data center architecture. On the right, our new architecture. The only thing that we asked our clients to implement was to introduce a country code in the calls that they were doing to our API. Using this country code, we implemented a routing logic that was allowing us to redirect the transactions to the cloud when it was needed. So if we take an example, let's say that a US transaction is supposed to be processed in the data center. If we receive this call from the cloud, it would be routed by our proxy and sent to the DC. If the same call happens in the DC, then it's okay. It's also happening directly in the DC. Now, if there is a French transaction, and if we want this transaction to be processed in the cloud, the API remains the same, the endpoints remain the same, and we just route this transaction into our new system for processing and a secure storage in the cloud. If the same transaction is arriving from the data center, then we would also route it to the cloud from our DCI. For Shadowwrites, we introduced an SQS queue, and every time we were writing something in Cassandra, we also pushed it into SQS. And then it was just a matter of pulling it from SQS and sending it over back to the DC. So in the case of our French transaction, at the same time we write into Cassandra, we push it in the queue. And then it was just a matter of pulling it back, migrating it, and now we have all the data up to date in the data center. For our staggered migration, so as I said, we wanted to go country by country. And the only requirement that we had for that was that all the processors for a given country had to be implemented in the cloud before we could migrate that country into the cloud as well. So during this whole process, we also had to pay attention to several things. First of all, troubleshooting. You don't troubleshoot stuff the same way in the cloud than in the data center. It's not as easy as logging into a relational database and then executing complex queries. So we had to relearn how to troubleshoot stuff and get more familiar with tools and so on so we could do the proper job. Also, the DC application had a long history. So there were a lot of custom business logic and nuances that were implemented over the years. We wanted to make sure that we captured everything and that we were able to recode that same logic in the cloud as well. And finally, it was also important to partner with all of our payment processors to make sure that their platform was also ready to support calls coming from the cloud. And that's about it. So, do you have any questions?
Yeah.
Yeah.
So what does the cloud really need for the processor? What does it mean?
So the question is, what is needed, what the cloud needs for the processor?
Yeah.
So the thing is, some processors could expose a RESTful API, and then it should be a no-brainer. But some other, especially local processors, may have more rudimentary ways to connect to them, either using sometimes some leased hardware that we have in our data center, and that takes care of connecting to a secure line to them. And so we had to work with them at that network level. Also, because of the volume of the transactions that we are processing, sometimes the processor was not able to process all that volume through their RESTful API. So we had also to come up with some batch solutions and so on. Yes?
How long did it take you to make the transition?
So it took us roughly a year, a bit more. And the thing is, when we migrate such a big system, we wanted to be extra careful with all the steps that we were taking. So there was a lot of time when we introduced a new processor, moved a country into the cloud, and then really inspected everything, making sure that everything is running fine before we took the next step. I think I can take one last question. Yeah. Yes, sorry.
So you said that you published to Cassandra and SQS.
Yes.
Did one of those get priority over the other? Because otherwise you have to face potential problems.
So the important thing was that it was still remaining consistent. So in case anything was happening, we were able, even if not rolling back, at least making sure that it was raising the proper alarms, so we knew that something was going on. But yeah, you're right. The important thing was really to make sure that everything was remaining consistent, and that we are not losing any kind of data. All right. Thank you. Thanks a lot.